Welcome to Cosmic Discoveries, your ultimate destination for the latest and most astonishing revelations in space exploration and astronomy. Today, we have an incredible discovery that will leave you in awe. Strap in as we explore the mysterious and captivating universe unveiled by NASA's James Webb Space Telescope. The cosmos is far more enigmatic and exquisite than humanity could have ever imagined. According to NASA's James Webb Space Telescope, we are about to witness an astounding discovery in the field of astronomy. Get ready to be astounded as we reveal what scientists have found on Pluto. These recent observations have unveiled mysterious activities on Pluto's surface that have scientists and astronomers completely fascinated, feeding their insatiable desire to unravel this cosmic enigma. The very first images of Pluto during its encounter year were already remarkable, but the recent observations by the James Webb Telescope have taken our understanding to a whole new level. What exactly did the telescope observe on its most recent mission? Scientists have discovered indications of a catastrophic event taking place on Pluto. Data suggests that this event has significant implications for our comprehension of the geological past of this dwarf planet. A surprising amount of heat was detected coming from Pluto's surface. The James Webb Telescope's powerful infrared capabilities allowed for accurate temperature analysis, revealing that Pluto was likely struck by a massive object, possibly an asteroid or comet. This impact would have caused widespread destruction, creating a massive shockwave that reshaped Pluto's surface. Stay tuned as we delve deeper into this discovery, gaining knowledge about the James Webb Space Telescope and its astounding capabilities. The James Webb Space Telescope, also known as JWST, is now regarded as the most sophisticated telescope in orbit, surpassing even the Hubble Space Telescope. Its mission is to revolutionize our understanding of the cosmos, from its inception to the present day. One of the primary goals of the James Webb Telescope is to uncover the "let there be light" moment, which occurs when galaxies and stars first formed following the Big Bang. One of the most interesting missions of JWST is its deep field observations. During these investigations, JWST focuses on small regions of the sky for extended periods, allowing it to observe very distant objects and galaxies that formed just after the Big Bang. This enables scientists to gain a more thorough comprehension of the history of the early cosmos. Furthermore, the James Webb Space Telescope is expected to significantly advance our understanding of exoplanets or worlds outside of our solar system. JWST will provide vital information for the search for extraterrestrial life by using its sensors to scan for indications of potentially habitable environments and living species in the atmospheric compositions of these far-off worlds. An important first has been made with the detection of a violent dust storm on an exoplanet outside of our solar system using the James Webb Space Telescope. VHS 1256b is the exoplanet being studied, located about 40 light-years from Earth. This storm resembles more of a fog composed of rocks with dust particles made up of silicates, which are tiny grains consisting of silicon and oxygen, than the typical sandstorms found in dry desert regions. Known as VHS 1256b and occasionally referred to as a super Jupiter, it is much larger than the gas giant planet in our solar system, with a mass estimated to be between 12 and 18 times that of Jupiter. It orbits two stars at a considerable distance from the Sun, nearly 4 times that of Pluto. The remarkable discovery of the dust storm on VHS 1256 was made possible by the enhanced capability of the James Webb Space Telescope. The telescope used its mid-infrared sensor, MIRI, and near-infrared spectrometer, NIR spec, to study the light emitted by the exoplanet and meticulously separate its component colors to determine the composition of its atmosphere. The James Webb Space Telescope's main goal is to study the early stars and galaxies that formed soon after the Big Bang, but its cutting-edge instruments like MIRI and NIR spec have given scientists a rare chance to investigate exoplanets in a way that has never been possible before. Through examining these far-off planets' atmospheres, researchers intend to learn more about their makeup, climate, and possible habitability. The discoveries made by the James Webb Space Telescope not only provide an engrossing look into the secrets of a far-off exoplanet, but also hold the possibility of examining if certain exoplanets might contain elements necessary for supporting life. Methane and carbon monoxide in the atmosphere of VHS 1256b point to a heated, chaotic environment, opening up an exciting new research direction. Another spectacular discovery made possible by the James Webb Space Telescope involves WR-124, a Wolf-Rayet star. Data collected with the mid-infrared instrument, MIRI and near-infrared camera, NIRCam on board the telescope, has allowed astronomers to examine the processes involved in the formation of dust, measure the size and concentration of dust particles, and investigate how dust from nearby Wolf-Rayet stars affects the Milky Way's total dust content. This increased clarity is crucial because dust is later recycled in the formation of new stars and planets. By piercing through the thick clouds of dusty gas that conceal star-forming regions, the James Webb Space Telescope's infrared vision has proven beneficial in providing insights into star birth processes that were previously obscured from our perspective. This increased sensitivity and detail have expanded our ability to study star formation in other galaxies throughout the universe, in addition to giving us a better understanding of star formation inside our own galaxy. The telescope's ability to study exoplanetary atmospheres has already led to some groundbreaking discoveries. Hot Jupiters, gas giants that are located very close to their host stars, have proven to be the most straightforward exoplanets to study due to their powerful signal emissions. The first exoplanet data obtained with the telescope came from these fascinating giants, including WASP-39b, located 700 light-years away. The James Webb Telescope used a technique called transit spectroscopy, which examines starlight as a planet passes in front of its star. Through this approach, astronomers can identify particular compounds in the atmosphere of the exoplanet by detecting their distinct absorption lines in the spectrum. The quality and precision of the data from the telescope have exceeded expectations. Researchers found sulfur dioxide molecules in the atmosphere of WASP-39b. These molecules are the result of photochemical interactions between atoms and molecules in the atmosphere that are triggered by sunlight. The telescope's surprising discovery of sulfur dioxide confirms its ability to reveal previously undiscovered chemical reactions in extraterrestrial atmospheres. The James Webb Space Telescope is making great progress in studying smaller, Earth-like planets as well. It is now focusing on the rocky planets of the TRAPPIST-1 system. Although its small size and weak red dwarf star make it difficult to identify atmospheric features, JWST's advanced capabilities are expected to yield significant findings. Exoplanets, or planets orbiting stars other than the Sun, have long been suspected to exist. However, astronomers were unable to confirm their existence until the 1990s through the use of modern observational techniques. Since then, exoplanet research has become an exciting and rapidly developing field within astronomy. As the telescope continues to explore and analyze exoplanets, we anticipate exciting new discoveries that will deepen our understanding of the formation and evolution of these celestial bodies. By investigating the mixture of gases present in exoplanetary atmospheres, astronomers can learn a great deal about planet formation and the separations between planets and their host stars. Investigating the atmospheric compositions of exoplanets can reveal information about the potential presence of extraterrestrial life. Scientists are motivated to find these hidden truths by this possibility. Fresh discoveries from the 2015 New Horizons mission continue to yield valuable scientific data, even though the historic rendezvous with Pluto occurred nearly a decade ago. New Horizons gave humanity its first up-close look at Pluto on July 14, 2015, with the probe traveling just 7,800 miles, 12,500 kilometers above the cold surface of the dwarf planet. The massive data collected during the flyby is still being examined by the mission crew. Current findings show that interesting discoveries are still being made. Most recently, New Horizons scientists presented their latest results at the Lunar and Planetary Science Conference in Texas. One of the latest discoveries linked Pluto's mysterious rotation to an ice-filled depression on the dwarf planet's surface. Fascinating but confusing landscapes were found, and scientists identified the elements that formed the snowman-shaped object known as Arrokoth, which New Horizons encountered on January 1, 2019. Pluto used to turn over on its side just like Earth does, regarding its orientation. More and more details about this mysterious dwarf planet's geology and atmosphere are becoming known thanks to the data gathered. Researchers are utilizing data from New Horizons to examine Pluto's geological past, and uncover clues that shed light on this event, including when it flipped and how much it adjusted itself. Some scientists link Pluto's reversal to the formation of Sputnik Planitia, a basin that is 1,000 kilometers wide and makes up half of Pluto's well-known heart-shaped region. Researchers already knew that nitrogen ice was present on the dwarf planet and that Sputnik had played a major role in altering its surface. Using images sent back by New Horizons during its 2015 flyby, researchers are currently tracking and examining Pluto's reversing trajectory. Parallel mountain ranges and deep valleys were found, and scientists theorize that these features forms part of a global tectonic system that extends to a similar distance from Pluto's North Pole. The breadth of these characteristics is more than 186 miles, 300 kilometers. However, evidence of Pluto's previous orientation change suggests that none of the landscapes currently observed are in their original locations, making it extremely difficult to explain Pluto's current configuration. Oliver White of the SETI Institute shared his insights, suggesting that these characteristics most likely originated at Pluto's equator and moved due to the flip to where they are now closer to the poles. Additionally, White's team found that Sputnik received some propulsion from Pluto's deep water, which helped to push the majority of the dwarf planet's mass towards its equator. In addition to helping scientists explore Pluto's ancient landscapes, New Horizons data also provides clues about the planet's more recent features. The probe had previously seen massive methane deposits, some of which were as tall as skyscrapers on Earth, close to Pluto's equator. Scientists have just announced that they have new evidence showing that these dagger-like formations might extend all the way to Pluto's far side. According to Ishan Mishra, a postdoctoral scholar at NASA's Jet Propulsion Laboratory in California, determining these characteristics advances our understanding of the ways in which functions influence the formation of dwarf planets like Pluto and other icy worlds in our solar system. Mishra clarified that these complex structures show the ongoing changes observed on planetary surfaces, similar to those observed on Pluto. By recognizing these traits, we can learn more about the processes that form celestial entities like Pluto and other frigid planets in our cosmic neighborhood. These structures, which are made of frozen water and only a few meters long, are referred to as penitentes on Earth. However, on Pluto, these features are found hundreds of meters above the surface, mostly at the highest peaks. Methane at those altitudes freezes out of Pluto's thin atmosphere during cold seasons and re-evaporates into gas during warmer periods. The current research team conducted their analysis using photos taken by the Long-Range Reconnaissance Imager, LORI, aboard New Horizons. By examining how light reflected from surfaces varies with viewing angle, they were able to identify similar structures of methane absorption on Pluto's far side. Mishra claimed that Pluto's surfaces were rougher than they should have been, and mentioned that one of the planet's most common traits should be these bladed landscapes. New Horizons also interacted with Arrokoth, a small object in the Kuiper belt that resembles a slightly flattened snowman. After being found 4 billion miles, 6.6 billion kilometers, from Earth, it became the farthest object ever studied by a spacecraft. Its isolation from sunlight keeps it in a deep freeze, making it the most primitive object ever studied. Experts believe that Arrokoth is the product of the slow merging of two objects that were once in orbit around one another. The largest of the two lobes is a mound of 12 stones centered around a larger slab. The Arrokoth formation, according to the most current findings, formed from pre-existing rock fragments in the outer regions of the solar system, rather than as a single body. Alan Stern of the Southwest Research Institute in Colorado noted that this is surprising and adds a new piece to the puzzle of how planetesimals, the building blocks of planets like Arrokoth and other Kuiper belt objects, come together. The massive donut-shaped region at the edge of the solar system known as the Kuiper belt was created early in its existence by millions of frozen particles the size of kilometers. Stern contends that the reason Arrokoth is so elongated is because just a small number of these particles joined to become Arrokoth, and they did not merge quickly. According to Stern's research, the rocks would have traveled at a speed of less than 1 meter per second if they had retained their shape after merging. Arrokoth interacted tidally with the smaller of the two objects, and after ejecting debris, both lost angular momentum and eventually combined to form the modern Arrokoth. Stern noted in his conference talk that the individual rocks resemble Lego pieces with identical sizes, compositions, and colors, all of which tell us something very important about the formation of Arrokoth. Every one of Arakoth's 12 rocks is more than 3 miles, 5 kilometers, broad. Astronomers assume that the 12 rocks centered around Arakoth's equator make up the majority of its body and continue to its far side, which New Horizons was unable to observe. James Keene, a doctoral student at the University of Arizona's Lunar and Planetary Laboratory, published the results on November 17th. Keene's study led him to these conclusions, with the study also benefiting from the work of his advisor, Assistant Professor Isamu Matsuyama. They presented proof of frozen nitrogen pileup, which would cause global disorientation akin to a spinning toy with a chewing gum clump attached. According to Keene, there are two methods to alter a planet's spin. One prominent alteration is the spin axis's reorientation with respect to the rest of the solar system due to a planet's shifting obliquity. Real polar wandering, according to Keene, is an alternative method in which a planet spins while keeping its constant spin axis placement in relation to other celestial bodies in our solar system. The direction of planetary rotation is generally toward minimizing energy consumption. This basically indicates that planets like to reorient so that any excess mass is concentrated around the equatorial region and any mass shortage is concentrated toward the pole. Keene explained that Pluto's orientation change is similar to what would happen if a massive volcano emerged on Earth and caused the planet to reposition itself such that Los Angeles is on the equator. In order to understand polar wandering on Pluto, one must first realize that the planet resembles a tilting, spinning toy. Unlike Earth, which has a slight tilt in its rotation, causing the equatorial regions to get the most sunlight, Pluto's equatorial regions are perpetually exceedingly frigid because it is around 40 times farther away from the Sun than Earth is. This small creation of rock and ice takes about 248 Earth years to complete one revolution around its axis, with temperatures plummeting to over 400 degrees in areas near Pluto's equatorial lower latitudes, which is cold enough to solidify nitrogen. Nitrogen and other unusual gases condense on Pluto's permanently shadowed regions during its complete cycle around the Sun. Seasonal snowfall occurs on Sputnik Planitia as a result of the frozen compounds heating up, condensing, and turning back into gas as Pluto revolves around the Sun. Keene noted that Pluto's heart stores a tiny quantity of nitrogen with each orbit around the Sun. Once enough ice builds up, it may eventually be as thick as 100 meters, overrunning the planetary structure that dictates its orientation. Keene went on to say that more mass will tend toward the equator if it is located in one area of the planet, leading to slow displacement over its entirety over millennia. Pluto possesses some traits of a dwarf planet, and its weather has a direct bearing on its formation and orbit around the Sun. Few people, according to Keene, had ever thought of the idea that volatile molecules could pull an entire globe along with them. The two researchers used observations collected during the flyby of New Horizons and combined them with computer-generated models. Using this method, scientists were able to alter a specific feature on Pluto's surface, such as Sputnik Planitia, move it around different parts of the planetary geography, and evaluate the impact on variations in the spin axis through geospatial analysis and simulations. As predicted by the models, Sputnik Planitia's location proved to be very close to its predicted location. If it were a massive positive mass anomaly caused by the loading of nitrogen ice, Sputnik Planitia would naturally shift toward the tidal axis shared by Pluto and its largest moon Charon as it approaches its lowest energy state. Large-scale ice buildup would eventually level off at a location where Pluto's spin axis is least unbalanced. This suggests that Pluto is currently experiencing the same dynamics as other celestial bodies, with geological faults indicating that there was once an underwater ocean on the planet. The process of turning water into ice requires planetary-scale expansion, resulting in surface disturbances like contemporary faults. A study published by Francis Nimmo of the University of California, Santa Cruz, and collaborators supports the theory that tidal forces can explain Sputnik Planitia's current location. However, for their concept to work, Pluto must currently have a subterranean ocean. The unexpectedly high degree of activity seen on Pluto is highlighted in both articles. Before New Horizons, most people associated volatiles with a thin layer of frost. According to Keene, the mission's results suggest that volatiles shape Pluto's terrain to a significantly greater extent than previously thought. The influence of volatiles in changing ice on Pluto's terrain is much more significant than anyone could have imagined. The latest developments from the James Webb Space Telescope have sparked global excitement and curiosity. Its recent discovery of a strange object moving on Pluto demonstrates its ability to propel scientific advancements. The quest to unravel the enigmatic mysteries of the cosmos continues. This unfolding narrative of remarkable discoveries will surely ignite discussions on the astounding feats of human ingenuity and the amazing marvels discovered in space. As we continue onward, the James Webb Space Telescope serves as a symbol of our common desire to explore the cosmos and solve all of its mysteries. It promotes an innovative and exploratory mindset that transcends national boundaries and unites people worldwide in their pursuit of enlightenment. Even while questions may still exist, it's important to remember that scientific progress is fueled by these groundbreaking discoveries. They inspire the next generation of physicists, astronomers, and explorers. We look forward to the next scientific finding that will capture the interest of society as we continue to explore the unknown. Thank you for joining us on this incredible journey. Don't forget to like, comment, and subscribe to stay updated on our latest videos. Let us know in the comments. What do you think about these new findings on Pluto? What other mysteries do you hope the James Webb Space Telescope will uncover next? Until next time, keep looking up at the stars.